Now we're going to look at some similar figures, and we're going to solve the find a missing side length. And in order to do that, we also have to kind of recognize which sides and angles are corresponding and congruent. And so we see here we have triangle WUV and we have triangle ZXY. Because right here we should see this is a right angle, we know that angle U and angle X are corresponding angles. They're also congruent. They're both the same. They're both 90-degree angles. Z is also a congruent angle with W. These two angles, because the figures are similar, these two correspond, they match and have the same angle measure. And angle V matches and has the same angle measure as angle Y because the figures are similar. So these two figures are similar. They also have, not only do they have corresponding angles, but they have corresponding sides. In this case, side WU is corresponding to ZX. You can see that because we go from this angle to the right angle, the angle with the one mark to the right angle. Side UV corresponds to side XY. And in this one, we're going from the right angle to the angle with the two marks, right angle to the angle with the two marks. So those two sides are corresponding. And then side VW corresponds to side YZ in this case. And so because we know that similar shapes have proportional corresponding sides and congruent angles, we know that these angles are all the same. We also know that these side lengths are proportional. And so I'm going to set up a proportion that this side 20, which corresponds with 4, I'm going to put 20 over 4, is equal to this pink side, the bigger pink side, which is X, over the smaller pink side, which is 7. So notice that I went from the big figure to the small figure, big figure to the small figure. 20 over 4 equals X over 7. Order is going to matter here. From here, I can solve the proportion using cross products and inverse operations. I may need my calculator to help me do some math, just to save me some time, even. And in this case, X is equal to 35 meters. Meters is my label. When I think about does my answer make sense, could this be 35? Well, if this is 20, this is longer than 20, so 35 makes sense. 4 times 5 is 20, 7 times 5 is 35, and because they're proportional, that also seems reasonable, and my answer makes sense. So in figure 2, we have similar figures again. This means that matching angles are congruent. A and E, D and H, C and G, B and F. All of those angles correspond to one another, A and E, D and H, G and C, F and B. And they all are congruent, which means they have the same angle measure. Then when we look for corresponding sides, we can see that DC matches HG and CB matches GF. And those are the two sides that we need to know in order to find our missing side length of X. Now, in this first one, we went big to small when we wrote our proportion. The other thing that we can do is we could go green to yellow equals green to yellow. So I'm going to do it a little differently this time. Green 13 over yellow 15 equals green 39 over X in the yellow. I'm going to solve using cross products. I'm going to use my calculator to save me some time. Then I'm going to use inverse operations to find the value of X and isolate my variable. And when I do that, I'm getting X is equal to 45. And then I'm going to add a label, millimeters. Does my answer seem reasonable and make sense? Well, the yellow side was a little bigger than the green here. The yellow side is a little bigger than the green here. If I go from 13 to 39, 13 times 3 is 39. 15 times 3 is 45. So my answer checks and seems reasonable. So I just want to show you really quickly that this does work. I want you just to kind of see this really quickly. That we can do green to green, yellow to yellow, or we can do green to yellow on the small and green to yellow on the big. So here we did green to yellow, green to yellow. We also could have done yellow to green, yellow to green. We just have to keep the order the same. Or we can go small to big, 13 over 39 equals small to big, 15 over x. In this case, we get 13x is equal to 585 again. We divide both sides by 13, and we get the same answer of x is equal to 45. We just did it a different way. So order does matter, but there are a couple different orders that you can go in when you're setting up these proportions. It's just really important that you pay attention to the order and know which order you're going in. Whether you choose green to yellow, you choose small green to big green, small yellow to big yellow, or you choose to go yellow to green on the small and then yellow to green on the big. So this next one says a flagpole casts a 20-foot shadow. At the same time, Barry, who is 6 feet tall, casts a 5-foot shadow. What is the height of the flagpole? In this case, we've got corresponding angles that are congruent. Here's my right angle. And so the tall side on my right angle is x here and 6 here. The short side of my right angle is 20 here and 5 here. And so I'm going to choose this time to go yellow to yellow, green to green. So big yellow x to small yellow 6 is equal to big green 20 over little green 5. So big to small, big to small. I'm going to solve using cross products. 5x is equal to 120. And then I'm going to use inverse operations. If I need to use my calculator to save myself some time, I can. 120 divided by 5 is 24. And so we would estimate this flagpole to be about 24 feet. So you can see how setting up proportions and using similar figures can help us when we're measuring things that maybe are too tall for us to measure on our own. There's no good way for us to measure a flagpole outside, but if we understand that we have right triangles with shadows, and the sun is coming at the same angle on both the person and the flagpole, which is true, then we can set up a proportion with our height and our shadow, with the shadow's distance, and then that can help us find that height of the flagpole, which we maybe can't measure on our own with a measuring tape. And so then number 4, the last one of this video, a water tower casts a shadow that's 20 feet long. So here's my water tower. Its shadow is 20 feet long. A tree casts a shadow that's 10 feet long. Oh, I'm sorry, a tree that's 10 feet tall. So the tree is 10 feet tall. Casts a shadow that's 8 feet long. So here's our sun all the way up here shining, and it's got the same angle for both. So now I'm just trying to figure out how high is the water tower. So I drew a picture to help myself here. Here's my water tower, which I'm not an artist. And then here is my tree. I'm going to write a proportion where I do the height of the water tower over the height of the tree. So h over 10 is equal to the shadow of the water tower over the shadow of the tree. Notice I did water tower to tree, water tower to tree. I went in the same order. You also could have done height to shadow, height to shadow. Either one of those proportions will work. Or shadow to height, shadow to height. It just matters that you go in order when you set up your proportion. That your numerators represent the same thing. In this case, the heights or I'm sorry, in this case, the water tower, and that your denominators represent the same thing. In this case, this represents the tree. So height of water tower over height of tree equals shadow of water tower over shadow of tree. And then we can use cross products to solve in inverse operations. Handy dandy calculator will save me a little bit of time in longhand. 200 divided by 8 is 25 feet. And now I'm asking myself, does it make sense that the height of a water tower is 25 feet? That seems reasonable. The shadow was a little bit shorter than the actual height. Here the shadow of the water tower is 20 feet, which is a little bit less than the height. Everything seems like it makes sense and is reasonable for our answer.